We're doing the addition rule for probability, and we'll start with an example which might help here. If one card is chosen at random from a well shuffled deck, what is the probability that the card is a diamond or a jack? Okay, so there's the word or there. So you need to understand your standard deck of 52 cards. This is not a video to tutor students about what a deck of cards is like, so if you don't understand a standard deck of cards, go back, find out, then come back to this video. Alright, so we've got one card chosen. Now we've got an or, we've got a sort of two types of categories here. It's instructive to draw a Venn diagram to help us out, so I'm going to call this one J for jacks, and this set here, the set of possible diamonds in a standard deck of cards. We know that in the number of elements in the set of jacks is 4. Okay, so the number of elements in the set jack is 4, and the number of elements in the set diamond is 13. Now, would it be right, this 4 here, would it be right to put a 4 here in like that? No, it wouldn't. And for the diamonds, would it be right to put 13 in there? The reason why it wouldn't be right to do those things is that these 4 elements here include everything, including the overlap for jacks, and also everything in D, the 13 elements, includes all the elements including the overlap. If you put those in, you'd end up, it's alright to count the overlap once, you have to, but you don't want to count it twice. So that brings us to how would we do it when there's some overlap, when there's an element of intersection. And what I mean by that, when we're talking about jacks and diamonds, there's this card called the Jack of Diamonds. That is both, and that card resides in here. There's one of those. Okay, so what we can do now is reason. So there must be 3 other jacks, and there must be 12 other diamonds. So answering the question, jack or diamonds, that basically will accept anything inside this entire zone here. So I would just need to choose an appropriate color. So all the way through, I'm not going to color everything meticulously, I'll just be pretty loose with that, but you get the idea. All the way through everything is or, but of course it would be wrong to double up, as I said, in the overlap. So what we would do is we would write the following, so that we've basically got the probability of J in union with D, because that's a union situation, is the probability of J plus the probability of D minus 1 lot of overlap. Remember, we counted it twice, so we need to minus 1 lot off, because the Jack of Diamonds would be counted in here and in here, so that's twice, and there isn't a 2 there, there's only a 1 in the intersection region. So we need to subtract 1 lot of the intersection, so that would be the probability of the intersection of J and D. Alright, now we just need to find these things. We need to find this, this, and this, and then we can substitute them into the formula. Let's do that then. So there's 4 jacks out of 52 cards, so the probability of a jack is 4 over 52. You could simplify that, but there's no need to at this stage. Probability of a diamond, selecting a diamond at random, is 13 over 52. Now, what's the probability of this here, the intersection? Okay, well, there's one card intersecting, one card that's common to both categories, the Jack of Diamonds. So it's the probability of the intersection of jacks and diamonds. That's intersection there. So it's 1 over 52. 1 over 52. So 4 over 52 plus, notice there's a good reason why I didn't simplify those before. They've all got the same denominator. Okay, that's 16 over 52, which is 4 over 13, and it's around about 0.3 something. If you like a decimal, if you needed a percentage, you could go ahead and convert that. So in general, the addition rule for probability is as follows. Here it is, and we have, if we have probability of A union B is the probability of A plus the probability of B minus one lot of intersection. And if they're mutually exclusive, which means the sets are disjoint, it's purely just A probability of A plus probability of B, because there is no intersection. You could write the same formula down, but that would be 0 anyway, that last bit, because it doesn't exist. Mutually exclusive are disjoint, remember, so there is no overlap. Okay, so it's not like an extra rule, it's just like a special case where there are 0 elements in the intersection, because you can see they're disjoint.